Okay, welcome to the last video of this assignment where we hack into the server configured in the first video and retrieve the flag created in the second video. Here we go. So, as you can see, it says the challenge begins at HTTPS IP address of the server / index.html. So for us, 192.168.64.4, and then we've copied that, and it said, "Welcome to Securum, the trusted partner in digital file protection." So obviously the challenge has told us to go to the root of the web server to start the challenge. The challenge tells us the secret off the bat, which seems too good to be true almost. So let's put that in up here. So we go 192.64.4, and then we go secret, secret.text. Okay, and instantly it says forbidden. So what do we do now? So we know this is because the secret.txt file is readable only by root, and as the web server runs it as the user Apache, the web server cannot send the secret.txt file. The hacker doesn't know this, but they have to find some clues. So instantly they're drawn to the inspect function, and the main page has a little bit of a hint. It says HTTP response headers can store valuable information. Make sure you don't leave anything in it. Now, this hint is maybe even a little bit obtuse, but that's all right. We want to make sure this is absolutely doable for the person. So they're going to reload the page, and they're going to see this index.html. And under response headers, they see some interesting information. So as you can see, when we're looking at these headers, they have some weird X's in front of them. And what X's mean is that they're not a standard header, they are extensions. So let's look at this one, X file retrieve endpoint. It gives a CGI script. Maybe this could be the way in for the hacker. This is a simplified version, but most hacks do this. They try and get the system to leak information out. A real life example of this is the Heartbleed OpenSSL bug from April 2014. Suddenly, everyone was checking servers' HTTP headers to see if they were running vulnerable OpenSSL versions. So even showing that information gives a hack a head start. So let's call this dodgy sounding script /CGI bin /do CGI. Okay, we press it in, and boom. It says that we're not calling it correctly, and that it needs the name of the file handed to it. So it's the error missing parameter after /CGI bin /do CGI, no file found in search path of /HTML. It sounds like it returns a file. So let's try calling the CGI script and giving it the name of the secret.txt file. A lot of web servers have the HTML root directory and the CGI bin directory having a common parent directory, so we can tell the script to look in .HTML for the secret text. Let's try that. All right, so now we've done that. It says, here is the file you've asked for, .HTML / secret.txt. It looks like some sort of encoded text, but we're not sure. So what now? So looking at the headers, we see a new one, X encryption, and under it, it says web server private key. Maybe the system administrator thought that they were being extra secure, but they made a fatal mistake if they encrypted the file with the private key, because with the public / private key pairs, the public key is used to decrypt, and the public key is, well, public, and anyone can get it when they connect to the web server. So now let's jump over to the shell and do this from a chain command line. I'm on MacBook, so I'm going to be using terminal and yep. Okay. So first we're going to start with the command curl dash silent insecure http pipe it. All right. So let's run through this. So first, what we're going to do is we're going to curl to connect to the website via the CGI script, and then we're going to yeah, pipe it to AWK, which is like grep to get the lines we're interested in, which in this case is to get rid of that BR, to get rid of some of that HTML formatting that will be attached to it. Then we're going to send that to a file called download.txt. So, yep, and let's run that. And now when we cat download.txt, we can see we now have the encrypted secret downloaded right here. Okay, so then we are going to run this command. So what this is going to do is We're going to call OpenSSL, remember the toolbox and the analogy, and we're going to use another tool. This one is s_client, which is used to inspect TLS connections. We're going to inspect the TLS connection on our IP here, and obviously this would be the individual IP for the user/hacker. And we're going to pass this to extract the public key from the certificate. Obviously, we're going to get some of these things to standard to out some of that stuff using the to/dev/null command, and we're going to extract the public key from the certificate using another tool. As you can see, OpenSSL, another tool from the toolbox, X509 into securum.pub. So let's run this, and let's cat the file. So securum.pub, and there we go. So now we have the public key extracted into our downloads. So one last step now. So now that we've done that, we're going to use the OpenSSL tool once again to decode the base64 download.txt file back to the binary decryption, then decrypt the string back to the original secret string using the PKE, using the private key encryption tool, and we're going to use the verify recover. And once we've done that, you're going to see it prints possibly our flag. So now we're going to Command C, and we're going to put it into the website from here. And let's have a look. Yes, super secret file, well done. So there we go. That is a complete run through of how to do the capture the flag challenge using all the decryption, encryption, tools, and how to exploit the vulnerabilities of servers whilst demonstrating real life examples. Thank you very much for listening. This has been the final part. Um, Obviously, there'll be more explanation given in the markdown on the cookbook and an explanation of the real world applications in the slides. But thank you very much for listening.